Alright, so the damage model has been made it to the tank. And I colored it invisible. But now I'm getting ready to move on to the mobility part, and that should be all for now. Or that should be the last part. So, in case you didn't realize that I'm a degenerate, this is my drivetrain. And that is a prop engine. It's a V12. So, one thing that is unfortunate is that I built the engine before the tank. So, unfortunately, you won't see me build an engine right now. There's still some things I need to do with the engine to configure it properly for the 70-ton tank. I'm not going to show you how to use ACF in this particular tank. If I do a proper tank with a turret and actually meant to fight an ACF, then I'll show you how to set it up with ACF, which is a very similar process because the engine rotates the gearbox and the gearbox rotates the wheels. So I wanted my engine to be mounted because it adds some physical weight and that does affect my center of mass. So I believe the center weighs like almost 2 tons. Alright, this is probably kind of pointless, but I thought I'd go over it again. Or just go over it here, in case anyone's wondering how I'm going to do my constraints. So, this is good old reliable. This is a wheel that just axis centered to the base plate. Oh, I don't have constraint remover. That's unfortunate. But, one constraint per wheel, and it's just from the side of the wheel to the base plate. Also, all of these little plates here are the same weight, and the wheels are as well. But yeah, this will hold the tank up. Pretty strong. If you wanted it to be stronger, I believe you increase the weight of the wheel. And another thing that's unfortunate is I did not make my wheel spherical before I did this, but it should get the point across. This is something pretty common people do for cars and tanks, but this is elastic suspension. So quite a bit more going on. These two ropes are rigid ropes. They make a hinge. So if you could imagine the wheel is on a circle, it just travels like that. There's an elastic. That's the spring. And there's also a ball socket to keep the wheel from rolling left to right because the ropes only go to the center of the wheel, so it's free to do whatever it wants. It can do whatever it wants to do if the ball socket wasn't there. So, for what it's worth, you can control the constant damping to make it stronger or like weaker. Basically change the spring rate. And if you're gonna make it out of elastics, I love having this tool around. This is a real elastic. It doesn't work if you just update it on something that's out though, so it just breaks it. It doesn't. Either way. So there's a more common method of doing suspension. And also something that just kind of works for tanks in general. Axis center, because tank wheels don't need to steer at all. And this is degeneracy. So if I actually look at this, you can see the elastic is over here, connected to something. There's an axis over here, connected to something. And the wheel has an axis. So this is a wheel hub. And this is what the axis and elastic is attached to. So this is axised over here to the base plate, and so it can, just like the ropes, swing around like that in a circle. And the elastic is back here. It doesn't have to be over there, but it is. And to connect the wheel, all you need is another axis. Now with this, I've used it on the vehicle and I'll show you it in a little bit, but the wheel technically can move left and right, and like get out of joint a little bit. It's barely noticeable, but more noticeable than a rope, which is very sturdy. Or 2 ropes, I should say. And again, relying on a physical prop because degeneracy. So usually I haven't used this very much, but half the weight of the wheel seems fine. Also, I usually have to edit the inertia on this thing, on the hub, because if I don't, it starts freaking out. So I just set it to 50 over here. And there is absolutely nothing special about this. It just very similar to the elastic over there. But let me show you that vehicle I was talking about. Oh look, the engine is over here instead of over there. I mean, it is over there too, but maybe I may or may not have done some testing with the engine before I built it, or while I was building the thing. But so this is using that suspension. If I fade the wheels, you can see what I'm using as my hubs, and all of these have an inertia of 100. And these are very heavy, and the wheels are even heavier actually. If I go ahead and take a look at what inertia I have these set to, not that, nope, this, not actually that high of an inertia. So why are the wheels and the hubs very heavy? Before that, I'll actually want to take a look at the constraints here. So there's an axis to the wheel, and where are the other constraints? Where are the other constraints? Okay, there's an elastic all the way over there, which you might be kind of curious about. Oh, there's the axis. So you see this sort of wacky setup I have going. The axis doesn't actually have to be that far out. The further out you have it, the more it looks like the wheel is moving straight up and down, which wouldn't be the case on an actual torsion bar. But why is the elastic that far out there? Well, I also want to point out the weight of the vehicle. It's 41 physical tons. So you might be able to see what I'm getting at here. And another thing is that this is only one elastic per hub. And if you actually look at the constant on the elastic, it's 7,000 and 700 for the damping. And this thing weighs 41 tons. And the suspension is able to hold it. So pretty much that's... Oh, and one thing I forgot to mention is that on this, I parented the hubs directly to the wheels without a gate. And that seems to work fine. Because, well, I'm not sure if it helps, but I'm trying to reduce the lag this thing makes, basically, because you are technically relying on an additional physics prop, so parenting may or may not help. I parented it anyway and kept the constraints on there. But yeah, 41 physical tons, and it can hold the vehicle. And yeah, the base plate is like 25 tons. So yeah, that's pretty much the gimmick of what I have going here. Technically, for your constraints, you are relying on a hub. And basically, you are kind of like putting the elastic on a gear ratio. And you can do a similar thing for hydraulics, I imagine. Actually, that's what I'm doing for my excavator arm over there. The hydraulics are very far away from the axis of rotation, so... Oh, and yeah, this is weird because the angles actually do rotate around This does drive just fine. It doesn't like freak out when the wheel tries to rotate or anything. So that's just some weird constraints in physics and abuse, I guess. But yeah, this is the gimmick with this suspension, is that instead of having multiple elastics per wheel, if your vehicle is really heavy, you just really only need one, and it can carry very, very heavy vehicles. Alright, so the suspension has been fitted to the tank. Unfortunately, I didn't hide my hubs yet, but one interesting thing to note is that I did droop my wheels 6 inches before putting the suspension on, and I'll show you that. So, well, basically, you can see how the vehicle's sitting on the wheels now, and how it is when I spawned it. So, I didn't really show that, but they have been moved down. And the idea is that it takes up a bit of the travel to sit on top of the springs. So I just basically try and keep the height of the vehicle as if I was building it at first. And I can show the constraints for that real quick. Still no constraint remover, unfortunately. But so you can see I just have my axis for the hub over here. And the elastic is not stupidly far back, unlike the other one. And actually, I didn't have any weight imbalance on this. Well, actually there is, but especially if you move the arm. But it's like 0.3 degrees when I put it on level ground. But yeah, I'm running 28k constant for the elastics and 2.8k for the damping. Looking for constraint info. So if I do that again, there you go. Another thing is, oh, let me show my hub weight. 75. Well, wait, 175. I know I said about half, but I was trying to keep the weight of the vehicle down. And also the inertia on these. Initially I set these to 50. But I went ahead and set them to 80 because the vehicle started vibrating when I put it down. So, just when in doubt, add more inertia, I guess. And if you're wondering how I did that, that auxiliary function E2 can set my... Normally I use it for my road wheels, but I'm putting it on my hubs now. And that gets wired to an advanced entity marker over here. Okay. Another thing I went ahead and did was... The steering bar actually moves, and there's some really ugly gauges. Well, ugly needles for the gauges. The gauges themselves are fine, but just using the default S-Props one. But this stuff will animate, it's just not wired to anything currently. And the E2 I've modified. It's now hatches and misc hollows, so tailor-made to the vehicle. So you can see for the steering lever, I have a animation hollow over here, and all my basically the model for that gets created and parented to that hollow, and I can actuate it later. And for the RPM gauge and the speed gauge, or the speedometer, they're very similar. And I don't have a separate hollow to animate, I just sort of rotate the model around. Actually works out because that bevel, not sure what that is. It's like a, okay, it's a cam gear. I built a prop engine model and I couldn't tell what a cam lobe even, what a cam lobe is, so I think that should be it. Anything else? Now the last thing should be to hide a few more things, including the base plate and the hubs, and make it drive. Alright, so before I put get the drivetrain sorted out, so I kind of already been testing the engine on this test chassis here, and so the engine is fine on this one. It's basically 100% physical. However, this is not 100% physical. It's mostly not physical. There's some parented weight that basically won't affect the prop engine, because the prop engine only really cares about physical weight. So this thing makes about 1500 horsepower when I dynoed it. Basically, if I ran this engine on that tank at full power, it's gonna look very off, and by it's gonna look very off, the tank is gonna have more wheel spin than one of those top fuel drag cars. So you might be kind of curious about how ACF does it, and I'm gonna do it a similar way. All this is kind of pointless because it's a prop engine tank. It's kind of a meme, but if you actually go to your add-ons, it's basically gonna be SVN. So ACF, I believe, is going to be entities, engine, and I have Visual Studio, so that's how it's gonna open. No, I don't want to update, but somewhere in here. So I know this is kind of out of nowhere, and also this is ACF 2. I believe ACF 3 is the same sort of calculation, but basically the engine takes into account the mass ratio, which is a ratio of the physical mass to the parented mass, the unphysical mass. So if I actually go find that, yeah, here we go. Yeah, you can just see it's the physical mass over the total mass, which total mass is, okay, yeah, it was right there. But basically, I believe this gets all the parented entities. No, I haven't looked through this too much, but basically, physical mass times divided by the total mass, so that's physical mass and the parental mass, and that is a ratio. So for instance, mine would be on this particular tank, it's gonna be like 12.7 tons divided by 70 tons actually. So you can see like a physical over total. And that's why I said it didn't really matter on this tank, because it's basically 100% physical. So 41 tons over 41 tons is basically, 99.9% physical. And actually, I don't even have to do the calculation. I can just take the percentage, 18. So basically, I am going to multiply the thrust in my engine by 0.18. So I can actually show this off right now, but if I go ahead and do that, this is my ECU. Very cool name. So let's see here. Thrust. Where is it? Yeah, there we go, max thrust. So I can just put 0.18, well, 0.18 times 0.18. At idle thrust, it's probably going to be fine. I can do the same thing there, but also this needs to change. You know what, we'll just multiply everything. 0.18. That's fine. Now, I already I'm using inertia to simulate a flywheel as opposed to a fry wheel. I believe that's just burnt clutches. But I'm using crank inertia to simulate a flywheel, and I multiply my force by thrust by the mass ratio, and you're gonna notice that, well, first of all, if I don't do this, I'll let you listen to the engine. So you can hear how quick it revs. They're basically, yeah, the speed at which it revs gathers RPM. I'm going to let you listen to it now when I actually put the mass ratio in it. So you can see it doesn't work. So if you have any sort of flywheel on the engine, not only do I have to reduce the thrust, I also have to make my flywheel weaker. In this case, just lower the inertia, which I'm gonna just copy paste this. Now hopefully this doesn't explode because it's still connected to the gearbox, but actually it's going to explode. No, wire you to something? Okay, fine. Yeah, that's fine. So basically, a lot less inertia. Weaker flywheel. Should be fine, right? So you can see the engine is happy now, it's revving at about the same speed. Now another thing is, because you are technically running less thrust, you might not get to the same RPM range like like if your engine could hit, let's just say 1500 RPM before, that's pretty high, but you might notice it maybe peaks at like 1000 or something like that, because you are technically running less thrust. All of this is kind of pointless and kind of a meme because ACF exists and you can just use the engines, but prop engines are kind of fun. Okay, I should probably make it drive now. So I've made a few more modifications to this in preparation to actually make it drive, which is changing the button to open the hatch for the driver because I need space for my brakes, but I also shaved a couple millimeters off the armor here and there because, I mean, it's still basically 79 tons, but it's nice. So instead of 1.8 or 0.18, the number I'll be using is 0.185 now. It's a little bit lighter, slightly better horsepower per ton, and I do mean only slightly. So gearbox. Oh, I actually need to derate the engine on this one. So what I'm gonna do is open up this chip, and I actually want to add something real quick. So my E2s are always so experimental, and it's always kind of weird to actually finish stuff because there's, oh, I want to add this and oh, I want to add that. But what I'm actually going to do is a new variable to this one, and that way, nice. Okay, so that'll just make reducing the engines easier. So what is 250 times 0.185? Okay, so I did the math on that, and the new inertia is going to be 46.25, and that's important because I'm going to be using that number to basically help me tune the gearbox. So technically for the gearbox, you can actually just directly wire the gear props to the drive wheels, and that'll work too because as it turns out, just having the inertia on these stupidly high doesn't really affect tanks anyway. But when I built the engine, I built the entire power pack, so I have separate gear props just built into the engine. strange little aside that doesn't, it's actually entirely unrelated, but okay, so these were the settings I was using on that little test vehicle. So I was using actually I wasn't even using 500. I was using like 700, but the initial inertia at 1:1. But that was when the crankshaft had 250 inertia. So a good starting place would be double. So I guess 46.25 times 2. And you can actually put that in there, but I'm not paranoid, but I mean, I am paranoid, but I like to be able to see things, so 92.5. And the stock inertia doesn't really matter, but I usually like having that be a fourth, just as a easy reference point, so we'll just call that 25, I guess. And actually, I can just 125. Sensitivity, I believe I said in that gearbox video that this doesn't really matter, because both of these, the gear inertia and the sensitivity, are they both do basically the same thing. I really don't like that. Now, I wouldn't go above 1 on the sensitivity, and particularly like higher values for sensitivity will spaz out way, or real higher values for the sensitivity are more likely to spaz out, to say it like that. Because if you give something with low inertia a stupid amount of torque, the angular velocity just fluctuates way too much. So yeah, I usually like to stay around 0.5. You can go higher though. But as far as the gearbox, I have some gear ratios I set up. This is how you do a pivot gear, by the way. It doesn't have to be -1 gear ratio, but basically you have to set a gear as having a ratio of 0. And I have a final drive and some gear ratios that I might end up changing: 5-speed forwards and 3-speed reverse. And yeah, that should be it for the transmission. So, alright, so here we have a very cool E2, at least as far as the name is concerned. Similar to the one I put on the APC, but slightly newer. Slightly. Also, a lot of my E2s are named after the vehicle I mount them on. Wow, some of these don't have spaces in them. Terrified to update the animation E2s though, because that's all over it, but what about this E2? Oh yeah, so the driver is also the excavator operator, so I need to add an input here. Control state, I believe it was. Let me see. Hopefully I should just, nope, there's no underscore in it. Okay. Cool. Okay, so unlike the normal version of the drive chip, you can't wire link an engine because it's a prop engine. But I'm just gonna go ahead and wire up my faceplate. Okay, and that ratio array is going to... I just realized this chip is proprietary to my own gearbox, because that just goes to an array on the gearbox, the ratios. And I need that for determining the shift speed. RPM just goes to RPM on the engine. Oh, and I guess from everything else, so active from the engine. Oh, no, not to itself. I'm just gonna wire it to engine active so I can have my dumb starter sound play. But you could just wire that to the pad controller. If you even have an active on your engine. Throttle, the throttle. I'm gonna ignore this now. Gear. Oh, right, this version of the ship doesn't have a left gear, right gear. It's kind of just built around my gearbox. But I won't be using them, but I will go ahead and wire up the clutches. Well, left clutch and right clutch. Also, that's kind of nice. These will auto wire. Just slide it back and forth. Steer. So I probably should have named just the steer rate, but here we go. Because I based all the inputs on the ACF gearbox inputs. That CVT ratio I won't be using, but I'll just wire it anyway. Also, you might be curious about this base input on the transmission. That's how the vehicle has a reaction torque, so I'm just gonna wire it up for now. What else? I believe that's it as far as wiring everything. Now, I'm just gonna make sure my base plate's aligned. And that's important so the vehicle knows if it's going in forwards or reverse. So, yeah, that's aligned. And you might have noticed that for the longest of time I had this little E2 next to my vehicle, and I didn't really need it for this one, but basically this is an E2 that I didn't think of anytime sooner, but it would have been nice because if you've had the misfortune of using my heads-up display or turret control, there are a lot of alignment angles, but basically, assuming this points in the same direction as your vehicle, you can just look at something, hit T, and get the alignment angle like that. So, whoops. Back to the drive chip. So, it's aligned using miles per hour, save speed. I'm just gonna leave that to 10. Just gonna let all the power in. Oh, so this is something just kind of new. So rather than just slamming the vehicle into gear, it'll try and ease across this many executions in the E2. And I just have it set to 4. If you set this to 1, it'll still slam it into gear. So the higher this number is, so like 10 for example, the smoother the shift. I like 4. 4 is nice. Power band max and power band min. So rather than getting this from a wire link, you have to put this in manually. Now I'm not sure what the rev range of the new engine is. I haven't tested it, so I'm just going to leave it here, and I'll figure out when I try driving this around. Let's see. Oh, full size. This is also important because, and also the final drive. These are important because this is how the E2 comes up with the shift speed. So let me actually, what are these? 35s? Okay. These custom spherical radius, by the way, but I'm just going to do 35.5 transmission type, not using a CVT. Also, originally, this, in like the driving chip just for ACF, this only applied if you had a CVT, but now you can have your own gear ratio, or a special gear ratio, just for pivoting, even if you don't have a CVT, so I'll leave it where it is right now. I could even, 0.1 maybe. No, it's 0.7. Max shift RPM. So this is where some of the new stuff comes along. So basically this is the shift up RPM and it's offset from the power band max. So right now that would be 850. Because it's negative 150. It gets added. So you add a negative, it gets subtracted. Min shift RPM. Relative to the bottom of the power band, and the shift width. So this is a new one. So originally in the ACF version of the E2. Basically the vehicle, there would be only one really shift point, so whenever the RPM was greater than the top of the power band, that was basically the shift point. So if you were in a, let's just say gear 4, if your vehicle was below gear 3's upshift point, let's just say 35 miles per hour or something like that, you'd automatically shift down. So this sort of adds like a tolerance to the shifting. So rather than like trying to keep it at the very top of the power band, you can like basically relax it a little bit. So I'm going to leave this where, well, yeah, I'm going to leave it where it was at 200. It'll still debug, so let me actually see right now. What I get? Okay, that's too fast. I'll just change the final drive actually. So it's 0.5. Too fast. Let's do 4.8. 4.7. There we go. I wanted to get around 42 miles per hour top speed, because the test chassis had smaller wheels, so I was using a taller final drive. And I'm gonna turn that off. So remember 0.47. Basically, I'm trying to like speed match with a Leopard 2. Oh, I should rename this. You know, it's probably fine. It's a gearbox connected to the engine, so 0.47. Used to all the E2s being clustered together. CVT, not using a CVT. Oh, now we're to the steering. So one new thing. Technically, this could be ported over to the ACF version of the chip, but the double differential questionable as far as how well that thing works when actually used for steering. But basically, setting this to 0 will make the tank use brakes and clutches to steer. Setting it to 1, which is the whole purpose of the gearbox, or this gearbox in particular, because differential steering will allow you to steer via the differentials. So okay, so this is, the first number is still, well, lap speed. The second number, instead of brake force, is the like speed differential in RPM between the two wheels. So 60 RPM, 130. And I should probably just call the steering harder or something, because it's not really a handbrake. But the third number is still the rate of decay. And all of this is work in progress. Now, that's just for the steering. You can't brake via a differential. So, braking spacebar, braking auto brake. This is still the brake force. This is still the decay. So, I should probably set this to something. I was trying to engine brake with a tank, which feels better than you would expect. But I'm gonna leave it to 0 right now because that's still in here, and I'm gonna remove it. But turn rate. So this was on the APC, but it's not in the ACF version of the chip. The first number is how many executions it takes to be at your full turning power. The second number is how many executions it takes to go from your full turning power back to 0, basically. So if you're not hitting any keys, no steering keys. Angular velocity target. Okay, all of this was really present. I'm not sure what this is, actually. More experimental stuff. I'm just gonna leave this to 25. And that's about it new for the C2. Yeah. Now I do have to make a change because I don't want my control speed active when I'm trying to excavate in the tank, so I might just tie it to active. That's what I'm gonna do. And not control state. So I should just be able to do something like this. Do you believe? Oh, let me go ahead and let's call this a new version. So in case you're wondering why some of my chips are so high revision, I'm a saveaholic and I give numerical increases to like the smallest changes. So I'm gonna save that, make sure it saves. Okay, so I went ahead and ball socketed my drive wheel to the gear prop. Ideally, you would just use the drive wheel since that's technically a interior drive wheel, which is against the rules or something. I don't know. So we're gonna give this a test drive and see what happens. I actually want to see what's going on in gearbox here as well. So R should be open hatch. So far, so good. Oh. Okay, my gauges aren't going to work because I didn't wire them, but it's going to raise the speed. It gets kind of in the way. I have the wrong version of the transmission on me, I think. Yeah. Okay. Hang on. It's fine. We'll just go grab the transmission off of the other thing. I thought I saw a missing input somewhere, but oh. Yoink. And what I'm just gonna do is copy paste my settings into this one. So this should be the same, right? Oops. Let's see. What changed? I don't think anything changed. Okay. And I'm actually just gonna change the name of this because I'm paranoid right now. Oh yeah, and these can't be vectors anymore. They're numbers now. Yes, really. Okay, we should be good now. I think. Oh, well, yeah. I'm gonna go ahead and wire up that clutch. So the new version of this version of this transmission has like a primary clutch, so your wheels could technically still be engaged into gear, but not receiving power from the engine. And this is really slow at turning. It's technically working though. It's just incredibly slow at turning, actually. Okay, so the vehicle was turning really slowly. Now, the first thing I did was, originally my base plate had like 15k inertia. And I believe I set it that high because I was having some troubles with the excavator arm spazzing out, causing everything to spaz out. But really I needed to increase the weight, so increasing the inertia didn't help that, so I just set it to 5k. And it seems to still be fine with the excavator, but I thought that was why it was steering so poorly, because there was a ridiculous amount of inertia, but that wasn't it. What it probably was, though, was I just made it steer harder. So 90 90 RPM difference between the wheels instead of 60. And for the handbrake, I increased that as well. Also, I raised the AV target so it tries less to stop itself from turning the faster it turns. What I also did, which was probably unnecessary, was make the gearbox stronger. Now to do that, I actually needed a stronger flywheel, or just more inertia on the crankshaft first of all, because if I just increase the gear inertia more and more and more, eventually the engine and wheels will start spazzing out because it's too much for the engine. So increase my crankshaft inertia first, and then went ahead and gave it more inertia, or the gears more inertia. So that more or less made the steering more responsive. Another thing I did was it couldn't really pivot, so I lowered that some, and I might lower it even more. It depends. We'll see. I think I have to lower the pivot ratio even more. And also, because the engine is derated, I think it hates or doesn't really like the higher RPMs that much, because it kind of gets high RPM and the vehicle really stops accelerating. So I lowered that, the max shift RPM, instead of being offset 150, it's now offset 250. So well, that's about all I did. So those are the ETs I made changes to. Oh, and I need to go ahead and wire this up. Clutch. So my wheels are still all rubber, S-Props rubber, which is very grippy. But I'll have to. This is where I just have to go test the vehicle and fine tune it some more. But now it actually steers. So let me go ahead and save this version, and I'll show you. I believe R opens the hatch. Still didn't wire my gauges, but yeah, the vehicle is pretty slow. Yeah, now the steering is more responsive. Steer even harder with the shift. Yeah, that pretty much killed my speed. But can it neutral steer is the question. Sort of. Yeah, the wheels are still really grippy. I might change some of them to paper and also raise that. That would probably help. Yeah. Right now, rubber's pretty grippy, even on like dirt. I think this is dirt anyway. I'm not sure what the road surface is here. But yeah, from here on out, some fine tuning. And this is basically where major work on a vehicle stops. So, yeah, that's been the Kodiak for now.